Hi, this is Mrs. Lewis, and we are recording live. Say hi, class. Hi, class. See, they can follow directions some of the time. Anyway, this is for 5th hour. Today is Tuesday, March 13th, 2018. And yesterday we talked about incomplete dominance and codominant. So for those of you watching, you can get a sheet tomorrow, but you will owe me homework as soon as you come in. So get out a separate sheet of paper, and you're going to work right along with us. Okay, so all you have to do is put the answers. You don't have to write the question or anything like that. Just write down the answers. Make sure you do your Punnett Squares. I will be grading it. And when I give it back to you, I will staple it back to this sheet so you can see what you did. So, SpongeBob loves growing flowers for his pal Sandy. Her favorite flowers, puffkins, are found in red, blue, and purple. Use the information provided and your knowledge of incomplete dominance to complete each section below. So it wants us to write the correct genotype for each color if R represents a red gene, and if B represents a blue gene. What would purple genotype look like? Somebody tell me, we're recording. RB, exactly. All right. So what would happen if SpongeBob crossed a puffkin with red flowers? Remember, if it doesn't state male or female, whichever comes first goes first. With blue flowers. Complete the Punnett Square to determine the chances of each flower color. So let's do the Punnett Square, which we should all be good at by now. Okay. What's the genotype and phenotypes for the offspring? What is it? Purple. The genotype is RB, and the phenotype, yes, Riley, purple. And how many of the plants would have red flowers? Pardon? 0. And how many of the plants would have purple flowers? And how many would have blue? One of the things I like to do when first learning is I will color code. So here's my R's. Those are red. Here's my B's. Those are blue. Okay? So if I bring my red down in every box that there's an R, and then I bring my blue over into every box that there's a B, you can see it's no longer red, it's no longer blue. It looks more of a purplish color. It doesn't show up as good up there on the screen. All right, let's do the next one. You guys do number 3, and let's see if you're right. Now that you've had a chance to work the problem yourself, as you can see, I color-coded. We took 2 hybrids, RB and RB, and we crossed them. So the genotypes and phenotypes for the offspring were RR, which was red. We had RB for purple. And we had BB for blue. So we had 25% of the plants as red, 50% as purple, and 25% as blue. If you missed Monday's lesson, go to Google Classroom and take a look here at March 6th. It said watch the link below. It's about incomplete dominance and codominance. After it gets done talking about codominance, you can stop the video. You don't have to watch the whole thing. Here's problem number 4. SpongeBob and his pal Patrick love to go jellyfishing at jellyfish fields. Fields are home to a special type of green jellyfish known as goobers, and only really great jellyfishermen are lucky enough to catch some on every trip. Many of the jellyfish are yellow, homozygous dominant Y, or blue, homozygous dominant B. But some end up green, which would be Y and B together, as a result of incomplete dominance. Use this information to help you complete the rest of the sections. Take a look at number 5 and number 6, number 7 and number 8. Same as before, if you're watching the video, the pedigree worksheet, the only thing you need to write down is the pedigree chart itself and the answers. No need to write down the statement or the questions. Okay, so you're going to need 2 different colored highlighters or 2 different colored pencils. Everybody ready? All right, so here we go. It says the pedigree to the right shows the passing on of straight thumbs, and they say that's recessive, and hitchhiker thumb is dominant. They also said the shaded shapes mean the person has a straight thumb. The first thing you need to do, first rule, hasn't changed at all. First rule is we need a key, right? So the key is we have a dominant. I'm going to use B because it's just easier to see it. So hitchhiker thumb is dominant. Okay. Go ahead and write down exactly how I am. So since we're not talking about a Punnett Square and we're talking about a genetic chart, it's saying the shaded shape means that the person has a straight thumb. So they're saying this one is shaded like this. And they're saying a hitchhiker thumb looks like that. Let me zoom in. I used to have you guys write for Punnett Squares, and I want you to go ahead and do the same thing. This genotype or this genotype could stand for hitchhiker thumb, whereas only this one could be straight. So your key should look something like that. Or your highlighters at this point, I want to show you something, okay? Let's take a look at Generation 4, Subject 1. We know that Generation 4, Subject 1 is going to be little b, little b. We know that because he's shaded. He has a straight thumb. So I'm going to think of alleles as colors. Okay? I'm going to think of alleles as colors. We know that Subject 1 got half of its DNA from mom and got the other half of his DNA from his dad. Because of that, we know that mom and dad both have to have the allele little b in their DNA in order to have a child that has 2 recessive alleles of little b, little b. Okay? Now, were either one of these shaded in? No, they weren't. They looked like this, right? So it either is going to look like this, homozygous dominant, or it's going to look like a hybrid. Well, we already know it's going to be a hybrid because it looks like a hitchhiker thumb, but it carries the trait for normal. That's one of the things that I do. If color coding is going to help you, then do it.
So that means that one's a little baby.
Say it again.
It's a little baby.
Yes.
A little baby, little baby.
So this is mom's DNA, and this is dad's. So, based on the genotype, question 1, what is genotype of Generation 4, Subject 1? I'm waiting for you.
Recessive.
Homozygous recessive. All right, number 2, what is the genotype of Generation 4, Subject 3? Is it shaded in? Okay. What is the genotype of Generation 3, Subject 1? Heterozygous. What about subject 2? Same thing. What is the genotype of generation 2, subject 3? Okay, so let's take a look at that. So here we have, I'm going to take away everything else, okay? This person here has DNA. They got this from a dad or a mom, and they got this one from dad or mom. But we don't know which one they got it from, right? We don't have enough information. So we're going to say this one could be this or this, and that's perfectly acceptable. So for number 5, it's big B, which is homozygous dominant, or it's heterozygous for the trait. So is it possible for generation 4, subject 2, is it possible for this to be a carrier?
Oh, yeah.
Yes. And the reason why, I want you to write this down exactly how I did it. Both parents had to be hetero-Z, which is a cross between 2 hybrids, in order to have offspring with this genotype. So our next case study is up on the board, and we can see they've already started us off with a key. They did give us a note. It said carriers are not shown on this pedigree, meaning there are carriers on this pedigree, but they didn't indicate so by doing the half circle or the half square. So let's go ahead and make our key. It says sickle cell anemia is a recessive disorder. So we know sickle cell anemia is going to look like this. Okay, little b, little b. And if they look like this, they're going to be normal. Or this would be their genotype. Okay. So I'm going to give you a hint for number 15. It wants to know which members of the family are afflicted with sickle cell anemia. Guys, did they name them Bob, Jim, or Mary? No. So you have to give it to them the way a geneticist would. So it would be generation 1, subject 1. And if there's nobody else in that generation, you end that generation with a semicolon, and then you begin with generation 2, generation 3, generation 4, and so on. Okay? The rest of these right here, 16 through 19, they want to know relationships like grandma, niece, uncle. Okay, those are the things they want to know there. And I'm grading you on this one, okay? So I'm not going to give you any answers. Check out 22. I'm going to give you another hint. One person can have more than one possible genotype. And here's your hint. There's 3 individuals that have BB or BB as their answer. There's 3 individuals in that pedigree that have homozygous dominant or heterozygous as their total answer.